Okay, welcome once again in this lecture video. This is the second part of the lecture video series on work and energy. In the previous video, I discussed about how to determine the work done by a constant force as if the motion is along a straight line. In this video, we will be talking about a more generic definition of work, okay? And that is by starting with the definition of the work done by a varying force. So, pag sinabing varying force, when we speak of varying force, always remember that from the word, of course, root word vary, that the strength of the force changes and it depends on the position of the particle. So again, varying force means strength or magnitude, okay, strength or magnitude of the applied force depends on position. Depends on position. So still focus our discussion on straight line, and then the straight line, let's have it as our x-axis. Okay? So in other words, force depends on position. We are saying that the force along the x-axis is a function of position. Ayan. So meaning to say, ang whatever is the value of x, magde-depend dyan kung ano ang kinakailangan na force. Now, so the more generic definition of work, no, makikita natin mamaya na whether if the force is constant, dito pa rin manggagaling sa definition of work na yan. So in general, the physical meaning of a work done by a force is equivalent to yan, our best friend. The integral of the applied force, and then of course, the integrating variable is the position. And then our limit would be from the initial position of the object, yung either nakatanggap ng force or nag-exert ng force, until the final position. Okay? So this is now, other authors would write it in a more generic term. So you can also say here that this is Fs, and then you have pwede ding F dot ds. Pwede ganyan. Okay? So from S1 to S2 or X1 to X2. But we will follow this labeling. Yan. Kasi in x-axis tayo. So, meaning to say, the force here na isa-substitute nyo, depende kung anong equation yan. So, say for example, if Fx here is, let's say, 3x plus 2, for example. So, edi yan yung ilalagay nyo dito and then you just do the integration. No? Ayan. Now, so what if Fx is constant? Kagaya ng first na diniscuss natin. What if Fx is constant? It's not varying. So, you learn in your integral calculus that the constant should be taken out of the integral. So the work done by that fx there is equivalent to, labas natin si fx, and then ang matira na lang dito of course is dx. Na, 'di ba? Merong invisible x to the 0 yan. So from x1 to x2. So if we further simplify, this becomes fx, and then the integral of dx is just of course x. And then limit is from initial position to final position. So further simplifying, this becomes fx upper limit minus lower limit. O di lalabas na yung alam natin, no, na this is f, x along the s, and then s. So that's for f, x, generic, constant. Constant siya. So ito yung nakita natin kanina. Ayan. Now, let's focus again on varying force. A very concrete example of a force that depends on position is the force we need in stretching or compressing a certain spring. So let's talk about force needed. Tayo muna ang nag-exert nito, ha? So what's the force needed to, let's say, stretch or compress a spring? A spring. Ayan. So, beginning today, magkakaroon tayo ng another best friend, no? The spring mass system. Okay. So, let's talk about force needed to stretch or compress a spring. Basically, this would be, let's call this as, let's say, F sub X. And ito yung, tawagin natin tong, in terms of pairs, action-reaction pair, this force that we need to stretch a spring for a spring mass system, this would be the force of, let's say, yung mass on spring. Yan. Force of mass on spring. So I am now introducing you to this very common system na pag-aaralan natin beginning today. We call it a spring mass system. So from the term itself, it's a system that's composed of a spring and a mass, of course. But the spring here is an ideal spring. When we speak of ideal spring, it becomes, in essence, it's massless. So in other words, the mass of the spring is very much less than the mass of the object tied to it. So essentially, the ideal spring, pwede nating tawaging massless. Yan. And then the mass here is just any object na itatali sa kanya. Either a box, usually it's a box. So, ayan. Let's define the equilibrium state or equilibrium position of a box. I mean of a spring. Yan. So, the spring in its natural length, that is where it is not stretched, it's not compressed. So, lalagay natin dito x sub 0 and then just use a broken vertical line. This is now the equilibrium state or equilibrium position of the spring. Where it's defined as the spring. The spring is in its natural length. Ayan. Natural length meaning not stretched nor compressed. Not stretched nor compressed. So, natural length siya. Ayan. So, ito yung, for example, yung natural length ng spring natin. And then, para maging spring mass system, lagyan natin, of course, ng, let's say, a certain box with a certain mass M. Kasi si spring walang mass. Yan. So, si spring, it cannot stretch or compress itself. Diba? Magre-react lang siya kung i-disturb mo yung equilibrium position niya. So, kung gusto mo ngayon na i-stretch siya to the right, edi natural, common sense will tell us na hilahin mo siya to the right, natural. So, lagay pa rin natin yung equilibrium position niya. And then, if we want the spring to be stretched this much, from here going to the center of gravity of the mass, for example, this is now x, which is the amount of stretching. Ayan. So, this, we're able to, the spring is able to stretch kasi nakatanggap siya ng force to the right. And by perspective, sabihin na lang natin na ito yung force ng box sa kanya. So this is now F sub X, the external force. Ayan. And then, whatever is the sign of the position. So kung gusto mong ang position is positive, edi itong force na i-apply mo sa spring, dapat positive din. Okay? So by Hooke's law, this is a statement that relates the force needed to stretch or compress a spring. So it's a saying that the force that you need to either stretch or compress a spring is directly proportional to the amount of stretching or compression that you'd like. So there's a direct proportion here. Linear relationship kay F at saka si X. Kaya kung gusto mong twice as far ang stretching, edi yung force i-apply mo, double the strength din. Diba? Direct proportion man. So we say that the force that you need to stretch or compress the spring is directly proportional to the displacement. Ayan. And then completing the equation, the force that all you need also depends on the characteristic of the spring, and that is measured by the spring force. So itong si K, we call it the spring constant, okay? It's also called as the force constant. So this is a number that tells you the stiffness of the spring. If K is a big number, then the spring is very difficult to stretch or compress. So for example, ang K value ng, let's say, shock absorber ng sasakyan. So the spring constant of a usual shock absorber of a car, kanang spring sa ilalom bitaw nga dagko kaayo, it's around 10 to the 5th newtons per meter. Yan. Ang unit ni K is newton per meter. Pero yung spring constant ng magic spring ng slinky is just around 1 newton per meter. So itong si shock absorber, kung gusto mo siyang i-stretch by 1 meter, kung kaya mo, so if X is stretch mo siya by 1 meter, kailangan mo ng 100,000 force, di ba? It's around 100,000 newtons na force para ma-stretchan siya ng 1 meter. Pero si Slinky, kung gusto mo i-stretch siya ng by 1 meter, kailangan mo lang ng 1 newton lang. Ma-stretch na siya by 1 meter. So that's what I mean by the physical meaning of K. It tells you of the stiffness of the spring. Yan. So, itong relationship na ito, class, na F is directly proportional to X, meron siyang limit. Ang limitation nito, the X should not be, tawag dito, there should be no permanent damage on the spring. No permanent deformation. Permanent deformation sa spring. Kasi pag in-stretch mo na siya, tapos hindi na siya bumalik sa original length niya, hindi na direct proportion yung force at saka ni X. Okay? So, something like that. Yan. So, therefore, since ito yung force na kailangan mo to stretch a spring or to compress a spring, then the work done by that force is, you have the integral of yung force na in-apply mo, and then dx, tapos x1, x2, di ba? Tapos, isa-substitute lang natin yung Hooke's law. So, si fx natin is kx. So, ito yung function natin for force, and then dx from x1 to x2. Okay? Yan. Therefore, since k nga is a spring constant or force constant, we take it out of the integral, and then ang matira na lang is x dx. Ayan, magaling na kayo dyan. Sub 1 x sub 2. So this is just k, and then power rule lang tayo. This becomes x squared over 2 from x sub 1 to x sub 2. So further simplifying, we have k, you have 1/2 x sub 2 squared minus the lower limit, 1/2 x sub 1 squared. Yan. And then finally, we distribute this there, and this becomes, rearrange lang natin siya, it becomes 1/2, and then you have the spring constant in Newton per meter, and then you have final position squared. This is either stretching or compression, no? Minus 1/2 k x1 squared. So this is now the work done by the external force. Ha? Pantayin ha, kay mag-agtuta karon sa work done by the spring. So this is the work done by the mass. But technically it's not the work done by the mass, no, but it's a certain other external object. Let's say tao niya gibira niya ang box, something like that. Kaya di man na siya pwede ibira sa box by itself. Nagilain. Pero by the work done by the mass on the spring. Now, kung baliktarin natin ang perspective natin, ano ngayon ang work done by the spring? Okay. Yan. So, balik tayo dito. So, dito ha, it's final minus initial yan siya ha. Balik tayo dito. If Fx here is the force of, so ito siya, if this is the force of M of the mass on the spring, then the spring will react. Magkakaroon ng reaction force. So, if you recall in Newton's third law, action-reaction, the force of one on a second object is equal in strength to the force of 2 on 1. Tama? Kaya lang, kung positive si 1 on 2, ito dapat pa negative. Kung ito pa negative, ang reaction force pa positive. So in this case, the interacting objects are the mass and the spring. It's the M here and the spring. So if this is the action force, then the spring will react. So, same strength, so magkasing haba pero opposite direction. So ito ngayon si F spring. F spring, and this is of course on the mass. Okay? Equal in strength but opposite direction. So we still use Hooke's law. According to Hooke's law, the force of the spring is also directly proportional to the amount of stretching or compression. It also depends on the stiffness of the spring, but you always have the negative sign here. Nga naman. Kasi po, kung ano ang direction ng displacement, whatever is the direction of the displacement, the spring force is always opposite to that. Take note. Spring force always opposite, kasi reaction force man siya, di ba? Always opposite to the direction of X. Yan. So, kung ang stretching is positive X, si spring force, negative dapat. Kasi hindi kasi pwedeng lalabas na negative si spring constant, si K. So, remember, if kinuha natin F spring divided by position, you get your negative K. Tama? So, kung negative si X, then meron kang negative dito, edi lalabas na positive K. Tama ba? Kung positive si X, magdi-negative si F, so negative times negative, positive K ulit. Okay? So that's one reason. K is always positive. At the same time, the spring force is a reaction force. If we take the Fx as the action force, although pwede man sila magbaliktad. So pag action-reaction, same strength, opposite direction. So since same strength sila, we are still using Kx. Pero lalagyan natin ng negative kasi nga reaction force siya. So anong mangyayari ngayon? Dito ngayon sa equation natin, pag nag-solve na tayo ng work by the spring, so work by the spring, this will now become negative Kx and then dx still from x1 to x2. So same process, kaya lang mag-flip ang sign. This will be magni-negative ngayon si final position. Tapos magpa-positive si 1/2 K initial position. Yan. So, let me put it again. If Fx is the action force and spring force is the reaction. So the work done by the spring is, unahin ko na lang itong positive ha. So magiging 1/2 kx1, sorry. Ito na lang. Gawin natin tong, I want the final to be, so opposite sila ha. Ito negative, ito positive kasi action-reaction. I-arrange ko siya in a more familiar way. So gusto ko kasing maging final initial. So ilalabas ko si negative para itong si 1/2 k x final squared magiging positive. And then ito dapat i-negative ko. 1/2 k x sum 1 squared. Okay? Final, now take note, 1/2 times the k times final times the stretching or compression squared. This is what we call elastic potential energy. It's any energy that you can store in any elastic material that is disturbed from its equilibrium. So whether it's disturbed by being stretched or it's disturbed by being compressed, the moment na you stretch or compress it, you're already storing energy that you can use anytime you want. Kaya it's potential energy. It has the potential to do work. Okay? So our symbol for potential energy is capital letter U. And then we have subscript L here for elastic. So this is elastic potential. Kasi meron pa tayong dalawang different kinds of potential energy. We have gravitational potential energy and electric. Kaya dapat may symbol tayo. So this is elastic potential energy. Ayan. Energy stored in any elastic material as it is being stretched or compressed. So naka-joule pa rin yan ha, kasi energy man. So if this is potential energy, then this must be final. So this is negative. And then 1/2 kx2 becomes U elastic final minus this one is elastic potential energy initial. So final minus initial, pwede nating sabihin as delta U elastic, pero may negative dito. And this is now the work done by the spring. Yan. Oops. Work done by spring. Okay? Yan. Pwede ring ito. Pwede saan dyan. Okay? So, this is the work by a spring, not on. Whereas dito, this is the work on the spring. This is work by the spring. Okay? And we will learn later kung ano ang physical significance ng negative tapos may delta U. Okay? Malalaman natin later na itong si elastic potential energy is only possible for conservative forces. Okay? Pag ang force hindi conservative, wala kang ma-store na elastic potential energy. And spring force is an example of a conservative energy. I mean, conservative force. Another conservative force is gravity, equal to the weight. So, F grav. Also another conservative force. So kung titingnan natin dito, the work by this conservative force, it's always changing the potential energy of a certain object. Okay? Whether it increases the potential energy or it decreases. Kaya later, we will also see that the work done by gravity will also be the negative of the U gravitational. So, hindi siya U-elastic, kundi U-grav naman. Next, ano na yan? Later video na yan. Okay? Now, I'm almost done. So, if we graph, therefore, the Fx versus the position, okay? This is not spring force, ha? So, iba din yung ilalagay natin sa, ano yan, ha? Oops, yan. So, for this case, pag 0 ang stretching, walang force na kailangan. So, Hooke's law. F needed to stretch or compress a spring has a linear relationship with X. No? Fx is directly proportional to X. So, this is linear. So, the best fit line, ayan, nasi best fit line. The best fit line is straight. Ayan. And then, whatever increase in the X, that is also the corresponding force needed. So, if I will plot a certain graph, it will always look like this. Nagid na siya. So, sabi natin kanina, if you have a force versus position graph, if you get the area under the curve, kunin ko ang area ng curve na ito. Let's say from here, if I take this as my x sub 1 and this is my x sub 2, I'll take the area of this curve under this curve, and obviously it's a triangle. What's the area of a triangle? So the work by Fx. So area of a triangle, I'll have 1/2. And then the base is x sub 2 minus x sub 1. And then my height is Fx. Yan. Pero si Fx, papalitan ko ng k and then the x also. So in this case, if I'd say x sub 1 is 0, tanggalin ko ito. So I'll have 1/2 x, generic x, say x sub 2. And then my Fx is, let's say, force constant of the spring times final position. So this becomes 1/2, and then I'll have k, and then my x sub 2 squared. This is if my x sub 1 is 0. Pero kung hindi, edi meron siyang, ang lalabas, kung hindi x sub 0, this would still be the work by Fx is 1/2 k x sub 2 squared minus 1/2 k x sub 1 squared. Okay? Something like that. Pero pag si spring force, it's inverse, merong negative dapat, di ba? So pag i-graph natin ngayon, si F spring versus, so dapat kung papuntang F, dito tayo. Yan. Nasa fourth quadrant. Positive si X position, pero ang force spring natin nasa negative spring force. Ayan. So, 0 force. Ayan. If I want to double it, I have to have a negative, ayan. So, ganyan siya. Ayan. This is now the graph. And then, if you want to get, you just get the area under a certain curve, under a certain value. So, pwedeng x sub 1 hanggang x sub 2. Okay? So, it's still, pero negative siya. So, mangyayari, the work by the spring will be 1/2. And then, ang base mo ngayon is still x sub 2 minus x sub 1. And then, yung fx mo is negative kx. Diba? Let's say negative kx2. Yan. So, we take this again as 0. So, we have, this becomes negative 1/2. And then, you have k x sub 2 squared. So, okay? Tama ba? Yeah. So, the work by the spring is always opposite to the, negative, no? Not always. Ito lang siya is for stretching kasi ito. Stretching. Yeah. So, merong mga times na positive, of course, ang work ng spring, di ba? So, for example, kung let's say galing siyang pagka-stretch, if this is the, yan. So, kunyari, ang initial niya is dito siya, initial, and then later, andito na ngayon, okay, 2. So, your x sub This is x sub 1 and then this is final position. So, yung displacement mo, ang change in position is papunta dito. Tama? Yan. And then, si spring force is also towards, remember, kalimutan ko pala, spring force, another term for spring force is, it's a restoring force. Ayan, ito pala yung pinaka-importante, restoring force. It's called restoring force because it restores equilibrium. It restores the equilibrium of the spring. Meaning, gusto niyang, so si spring force is always toward the equilibrium position. Yan siya. So that's one way of looking at it. So since ang equilibrium position natin dito nasa left ng box, so si spring force papunta din doon. Then the spring force is also there. And since the system is also going to the left, then in this case, the work by the spring force here this time is positive. Yan. Pag positive ang spring force, ibig sabihin, ang U elastic is going down. It's decreasing. Yan. Okay? Pag positive ang ginawa niya na work. So, kailan siya magpa-positive? Kung pareho sila ng, kung ang spring force, same direction with the displacement. Ano pa bang ibang example ng positive na work? Let's say, for example, if the box, ano naman siya? If the box this time is, let's say, so what else? If the box is being, if the box is on its way towards here, okay, so parang initially it's being compressed. So meron siyang initial compression, ganyan. And then later, binalik na siya somewhere, andito na siya ngayon, somewhere here, position 2. So ang pagbabago sa position, ang displacement is to the left, that's your S. Tapos si spring force, right pala. Si spring force, papuntang right din. Kasi yun yung location ng equilibrium. So si spring force dito, papunta doon. Ayan. Okay? But of course, there is this opposite and equal na external, di ba? Ayan. Pero ito, this is when it is moving na here. Ito na yung velocity vector niya. So in this case, the work done by friction, by the spring force is still positive. So, yung whatever elastic potential energy na na-store mo habang kino-compress mo yung spring dito, liliit at liliit yan hanggang magsisiro siya pag nakarating na siya dito. Kasi pag nawala na si X, wala ng elastic potential energy, di ba? 1/2 kx squared. Kung walang stretching, walang compression, edi walang na-store na energy. Okay? Kaya, we say that that is the physical meaning actually of the negative here in the delta U elastic. Okay? Whatever is the change in the potential energy elastic, yun yung opposite sign niya. So meaning, kung ang elastic potential energy nag-increase, ang work ng spring negative. Pag ang elastic potential energy bumaba, ang work ng spring positive. Okay? Basta kasi ang ibig sabihin lang, if the spring force is, if the motion of the object is also in the same motion with the spring force, that is going towards less and less potential energy. Kasi spring force, always manggit siya padulong sa equilibrium. Okay? I think that would be it's already long, no? So, at this point in time, we are now able to talk about the definition of the work done by a varying force. And the varying force that we focus here is the force that is needed to stretch or compress a spring, and also the reaction to that which is the spring force. Yan. So, same reminder, you solve similar problems on which applies these principles. Okay? Sige. Until then,